Hello, dear grade 12 students. Welcome back to my lesson. On today's lesson, we are going to solve the other questions that related with the rotational and translational equilibrium. In a previous lesson, we solved some questions in the practice and some questions in the chapter review. And we are still continuing to solving the other questions. Question 3 in practice 2b. The question says 400 Newton child and a 300 Newton child sit on either end of a 2-meter long seesaw. Okay, so how many gravitational force do we have? 2. Fg1 and Fg2. Okay, Fg1, which is the child is sit here at the end of this seesaw, its gravitational force is 400 Newton downward, and the other is 300 Newton gravitational force downward. Okay, so what is unknown in this question? We have two branches. Okay, branch A, where along the seesaw should the pivot be placed to ensure the rotational equilibrium disregard the mass of the seesaw? So in that case, we have to find the point of the axis of rotation, or the balancing point between these two child. As you know, for non-uniform object, for the uniform object, the balancing point located at the center of the object. But in that case, because we have two different weight, so is it possible to make a balance of a seesaw of two different weight? Yes, of course. Exactly how? By, for example, in that case, the balancing point is located near the heavier side. The balancing point for non-uniform object always located where? Located near the heavier side and away from the lighter side. So the balancing point or axis of rotation is located here. The pillar or pivot, it should be here, near the heavier side. Okay, so this distance is called d1. Okay, and this distance from the child with the 300 Newton is d2. So the distance of the entire seesaw was given in the question. It is equal to 2 meters. So it means that d1 plus d2 is equal to 2 meters. Okay, so in that case, d2 is equal to what? If we take the one to the other side, it becomes 2 minus d1. Okay, so because the question says the seesaw is at equilibrium, okay, so that is why we have to apply the conditions of rotational equilibrium to find the distance. Okay, as I mentioned before, to find distance, always you have to apply the rotational equilibrium. Okay, the rotational equilibrium says all the net torque is equal to 0. Okay, it means that all torques that acting because the balancing point or axis of rotation is located at the middle, so we have to equalize all torques that acting to the right and all torques that acting to the left. Okay, right torque is equal to what? The left torque. Okay, this is right torque and this is left torque. And also you can say the left torque is equal to the right torque. It's up to you. Okay, so in that case, now how many torques do we have in this side? We have only this torque. Okay, this gravitational force produces torque, which is equal to Fg1 d1. The other side, this child also produces torque, is equal to what? Fg2 d2. Now replace. Fg1 was given 400 Newton times d1 is unknown. Okay, this is d1 is equal to Fg2, the gravitational force of the second child, 300 Newton times d2. I rearranged it here before solving the question, was 2 minus d1. Okay, 400 times d1 is equal to 400 d1. Open this brackets, multiply both of them. 300 times 2, 600 minus 300 d1. Okay, so if you take this 300 minus 300 is d1 to other side, it becomes positive. It becomes 400 d1 plus 300 d1 is equal to 600. 300, 400 is equal to 700. d1 is equal to 600. So this 2 0 cancel. d1 is equal to what? Is equal to 6 over 7. So d1, finally, we found d1 is equal to what? Is equal to 0.86 meter. 0.86 meter from what? From the child with the heavier mass, with the heavier weight. Be careful. This distance is the distance from the axis of rotation to the child with what? With 400 Newton. So what about the distance of the child with the 300 Newton to the axis of rotation? Because d1 plus d2 is equal to 2. d2 is equal to what? Is equal to 2 minus 0.86. 0.86, which is equal to 1.14 meter. This distance is the distance from the child with the 300 Newton to the axis of rotation. Okay? How many distance do we have? Two distance. d1, we found d1 by using rotational equilibrium, and d2, after finding d2, we have to substitute into this equation to find d2. Okay? So is equal to 1.14 meter. Okay? Also, I mentioned here, so the gear with the 300 Newton placed at 1.14 away from the axis of rotation, and the gear with 400 Newton placed at 0.86 meter away from the axis of rotation. For example, if they bring this question in the Wizari, be careful. Both answers are true. Be careful, please. If the multiple choice says 300 Newton is placed at 1.14 away from the axis of rotation, is it right? Yes, of course. B, 400 Newton placed at 0.86 away from the axis of rotation. Yes, also this one is correct. So both answers are correct. Okay. This is branch A. Branch B. What is unknown in branch B? Okay. In branch B, suppose a 225 Newton child sits 0.2 meter from the 400 Newton child. Be careful. The question says a child of weight 225 Newton placed near 0.2 meter from what? 0.2 meter from the child with the 400 Newton. What is the distance between these two child? Is 0.2 meter. So you know that the distance from the axis of rotation, balancing point, to the child with the 400 Newton is 0.86. What about the distance from the third child? This is the third child, okay? FG3. The third child placed 0.2 meter away from the child with the 400 Newton. And what is remaining in this distance? You have to say 0.86 minus 0.2. So the distance, D3 distance of the third weight is equal to 0.66 meter. This is very important, be careful. Because we need the distance of the third child from the axis of rotation, not from the child with the 400 Newton, okay? This distance was given 0.2. So the entire distance from the child of 400 Newton to the axis of rotation, we found 0.86, okay? So we have to subtract 0.86 by 0.2 is equal to 0.66 meter. So the question says, where must a 325, this is FG4, 325 Newton child sit to maintain rotational equilibrium? The fourth child, it should be placed here, but I don't know in which distance. D4 is unknown. The fourth distance is unknown for the last child, which is sit here to prevent the rotational equilibrium of the seesaw. Okay, how can we determine this distance? To find distance every time, you have to use the rotational equilibrium. Rotational equilibrium, because the axis of rotation is located at the middle, all torque is that acting to the left is equal to all torque is that acting to the right. How many forces do we have in the left of the seesaw? We have two gravitational force. These two gravitational force, both of them produces torque. So that is why you have to say torque number 1 plus. This is the third child, be careful. This 225 is Fg3. Torque number 1 plus torque number 3 is equal to torque number 2 plus torque number 4. This is the torque of the first child. This is the second child, which is sitting the other side, okay? And this is the torque of the third child, and this is the torque of the fourth child, okay? Now, to find the distance D4 is unknown. Torque number 1 is equal to Fg1 times D1 plus Fg3 times D3 equal torque number 2. The gravitational force of the second child, 300 Newton, times it is distance from axis of rotation, plus the gravitational force of the last child, Fg4 times D4. What is unknown? This D4 is unknown. Okay? Fg1 was given 400 Newton times D1, we found 0.86 plus Fg3 225 times D3 was not given directly, but we found it 0.66 is equal to Fg2 300 Newton times D2. The distance from the child with the 300 Newton to the axis of rotation, D2 is equal to what? 1.14. Okay? D2 is equal to what? 1.14 plus Fg4 was given, okay, the fourth child 325 Newton times D4 is unknown. D4, okay? So all other quantities are given, so you can, by rearranging the equation, you can find D4, which is equal to 0.46 meter, okay? 0.46 meter from the axis of rotation. So this distance is 0.46 meter from the axis of rotation, okay? So to find the distance of the fourth child from the second child, you have to write down like that 1.14 minus 0.46 meter. If the question says, what is the distance between the fourth child to the child with the 300 Newton? You have to subtract 1.14 by 0.46. This is question 3 in chapter review, a very good question, you get it, okay? Let's go back to the sample problem. Okay. Sample problem 2B. This question has been brought in Missouri exam 2022, I think. It is very good question. Listen carefully, please. The sample problem 2B says a uniform 5 meter long horizontal beam. Okay. The distance of the beam was given 5 meter long. Okay. It is the entire distance of the beam is 5 meter. That weighs 315 Newton. Because the beam is uniform and it is center of the gravity, it is gravitational force is located at the center. We call it the center of the gravity. Okay? The center of the gravity of the beam is located at the center, at the middle, downward. This is Fg beam is equal to what? 315 Newton. Okay? Is attached to wall by a pin connection that allows the beam to rotate. Okay? So another end of the second end of this beam is attached to a wall by a pin, okay, and the beam that allows the beam to rotate. So it is far end is supported by a cable. It is far end is supported by what? It means that this end supported by cable, Ft tension force, and it makes an angle 53 degree with the horizontal. The angle makes with what? With the horizontal. Okay? And for 545 Newton person is standing 1.5 meter from the pin. This is pin. The pin is located here. Okay? So in this question, the figure is given. Okay? This is the reaction force of the wall by the beam, okay, which is equal to R, and the man stands 1.5. If someone stands here, it is distance from axis of rotation is what? 1.5 meter, and okay, this distance is what? 1.5 meter. So it is gravitational force is acting downward. Fg of the person 545 Newton. Okay, 1 meter, 1.5 meter from the pin. The distance of this person is 1.5 meter from the pin. The pin is the axis of rotation. Okay, find the force in the cable Ft and force exerted standing on the beam by the wall. Ft and R is unknown. Ft is unknown. R is unknown. How many forces unknown in this question? 2 forces are unknown. If 2 forces are unknown in the question, you have to use both conditions. Rotational condition at first and translational condition in the second to find R. Okay? Now to find Ft, we have to use what? Rotational equilibrium. Okay? Because the axis of rotation is located at the end, so that is why we have to equalize the torque is that acting upward and all torque is that acting downward. Okay? How many upward torques do we have? We have 2 upward torque. Because the Ft is not located on the y-axis and x-axis, it makes an angle for every force. For any physical quantity, when it makes angle, we have to resolve into 2 components. This Ft, this tension force, is not on the y-axis and x-axis, so that is why it makes an angle. So in that case, we have to resolve this tension force into how many components? 2 components. Fty and Ftx. Okay, because the angle with the x-axis, so that is why we have to use cosine with x according to Pythagorean theorem. Ftx is equal to what? Ft hypotenuse times cosine theta. What about Fty? Fty is equal to what? Because the angle is not with y-axis, so that is why we have to use sine. Ft sine theta. Fty is equal to what? Ft sine theta. So what about this R? This R also can be resolved into 2 components, Rx and Ry. Okay, now how many upward forces do we have? 2. Fty, which is equal to Ft sine theta, and Ry. Okay, so that is why you have to say the upward torque is equal to Fty, which is equal to Ft sine theta times, it is distance from the axis of rotation, plus Ry times the distance of the Ry is equal to, how many downward force do we have? 2. The gravitational force of the beam and the gravitational force of the person that's standing 1.5 meter away from the pin. Fg of the beam times distance of beam plus Fg of the person times distance of the person. What is unknown? Ft and R. Okay? How can you determine Ft? Substitute. Do we have Ft? No. Times sine 53 times the distance from the applied force at Fty is applied at this point. Okay? The distance from Fty to the axis of rotation is equal to what? Is equal to 5 meter. So D1 is equal to what? 5 meter. Write down here 5 meter plus Ry. The force of Ry is located on the axis of rotation. It is distance is equal to what? 0. So it means that this force cannot produce torque. That is why Ry times dy is equal to what? Is equal to 0. Okay? Why? Because the Ry is located on the axis of rotation. Fg of the beam was given 315 times the distance of the beam. The entire distance of the beam was given 5 meters. The center of the gravity of the beam located at the center. So we have to divide this 5 by 2. What is remain here? 2.5 and 2.5 here. The distance of the gravitational force of the beam to the axis of rotation is 2.5 time plus Fg person 545. The distance of the person was given directly in the question, 1.5 meter away from the axis of rotation. So how many unknowns do we have? One unknown. You can rearrange this equation. Ft is equal to what? Ft is equal to 402 Newton. This is the tension force of the cable that acting on the beam. Okay. The second unknown, we have to find R. Okay. Did you understand? Hope you get benefited and hope you get understood in this question, because it is a very good question. Okay. Listen carefully, please. Now we're going to solve R. Okay. Because we have two unknown in this question, Ft and R. R, what is R? Is the force of the wall that acting on the beam. Okay. To find R, because this R is not located on the x-axis and y-axis, we have to find the R by using Pythagorean theorem. R is equal to what? Is equal to Rx squared plus Ry squared. Why? Because R is not on the y-axis and x-axis. It makes an angle. To find this resultant vector, we have to use what? Pythagorean theorem. Pythagorean theorem says the hypotenuse is equal to radical adjacent square plus opposite square. Okay. Do we have Rx? No. Do we have Ry? No. How can you determine Rx? Because Rx is located on the x-axis. Where is Rx? Located on the x-axis. So that is why we have to use translational equilibrium. In translational equilibrium says all forces that acting to the left is to the right is equal to all forces that acting to the left. Okay, so it means that this Ftx is equal to Rx. Yes, of course. Okay, Ftx is equal to what? Is equal to Ft cosine theta. So Ft cosine theta is equal to Rx. Yes, of course. Why? Because the beam is at completely equilibrium. Okay. How many forces do we have on the x-axis? Two forces. Rx, which is directed to the right, and Ftx, which is directed to the left. Two opposite force equal in magnitude but opposite in direction. So Ftx plus Rx is equal to 0. So that is why Ft cosine theta is equal to Rx. Okay? Or Rx is equal to what? Do we have Ft? Yes, we found 402 times cosine 53. Rx is equal to what? Rx is equal to 242 Newton. This is Rx. We found Rx. Okay. Ry, because Ry is located on the y-axis, so that is why we have to equalize all upward forces to all downward forces. We have to use the translational equilibrium. Okay. All upward force equal all downward force. How many upward force do we have? Ft sine theta. This is upward force. Ft sine theta plus Ry is equal to the downward force, Fg gravitational force of the beam and gravitational force of the person. Fg beam, Fg person. Okay. Now Ry is equal to what is unknown. Take Ft sine to other side. Fg beam 315. Fg person 545 minus y, because rearranging the equation. Ft 402 times sine 53. Ry is equal to what? Ry is equal to 539 Newton. Replace it to this equation to find R. R is equal to what? Rx, we found Rx 242 square plus Ry 539 square. In this way you can find the value of R. Okay, so this is sample problem 2B. Very good question. Be careful. Okay. Another question in chapter review, I think. Yes, we solved question 18 already. Yes, and now you're gonna solve question 33. Question 33. Good question. Question 33 says a wooden bucket filled with water has a mass of 75 kilogram. Okay, what is this? This is the mass of the bucket that filled with water is 75 kilogram. Is downward. Is attached to a rope. Attached to what? To rope. This is Fg downward. Okay, which is equal to mass times gravity. That is wound around the cylinder. What is this? This is cylinder, okay? This is cylinder. With the radius of cylinder. What is this? This is the radius of cylinder. R is given, the radius of cylinder, 0.075. This is the radius of cylinder, okay? A crank with a turning, what is this? This is crank. Okay, a crank with what? With the turning radius 0.25. This is the distance of this crank is 25 meter. This is the radius of the cylinder, the distance from axis of rotation of the cylinder, and the radius of crank is equal to 0.25 meter. Okay, so how many rotational do we have? 2. The distance of the crank from the axis of rotation of the crank is 0.25 meter, and the distance from the axis of rotation of the cylinder, which was given 0.075 meter. Okay, attached to the end of the cylinder. What minimum force directed perpendicular to the crank? The force of the crank is unknown. Fg cylinder was given is equal to mass times gravity, but Fg crank is unknown. That requires to raise the bucket at constant speed. If the object has a constant speed, its rotational speed also is constant. So both translation and rotational equilibrium. The object, the system has both translational and rotational equilibrium because the object is moving or require raising with a constant speed. Okay, so in that case we have to use rotational equilibrium. Net torque is equal to 0. Okay, so we have 2 force and 2 torques. Okay, the torque of the crank is equal to the torque of the cylinder. Okay, how many torques do you have? 2 torque. When the force applied on the crank, this is F of the crank is unknown. The force of the crank, okay, is unknown, that acting on this distance. But the force of the cylinder, the gravitational force, is known because mass is given. Okay, so that is why we have to equalize these 2 torque. How many torques do we have? 2. The torque of the crank and the torque of the bucket. Okay, the torque is equal to what? F, the force of the crank, times the distance of the crank from axis of rotation is equal to Fg of cylinder times the distance of the axis of rotation of the cylinder. Okay, what is unknown? The crank force, the force of the crank, or rearrange the equation. This distance, it goes to the denominator, the distance of the crank, Fg. Instead of Fg, mass was given mass times gravity times distance. Replace. Mass of the bucket was given 75, gravity constant. The distance of cylinder, what is this? This is distance of cylinder, was given 0.075 divided by the distance of the crank, 0.25. By calculator, you can find the force of the crank, which is equal to 220 Newton. Okay? If you replace this force into this equation, these 2 sides must be equal. Okay? You can replace. This is question 33 chapter review. Okay? Question 35, the question of the screwdriver. A very good question, and it has been brought in Wizari exam many times. Listen carefully, please. A 23 centimeter screwdriver. This is the entire length of the screwdriver, okay? What is this? This is the entire length of the screwdriver from this point to this point. The distance of the screwdriver is 23 centimeter, which is equal to 0.23 meter. This is the whole distance of the screwdriver, okay? Is used to pry open a can paint, okay? This is used to open the can of the paint, okay? So, if the axis of rotation is 2 centimeters from the end of the screwdriver blade and a force 84.3 Newton is exerted at the end of the screwdriver. So, what do you mean by this 2 centimeters from the end of the screwdriver axis of rotation? It means that 2 centimeters, okay, this point becomes axis of rotation. Okay, why? Because the screwdriver, okay, it is rotating at this point. If you put the screwdriver into the can of the paint to open the prey of this can, you have to apply force to the end of the screwdriver, and this point becomes what? This point becomes axis. So how many centimeters inside this can is 2 centimeters? Okay, 2 centimeters. Okay, so the distance from this end to the axis of rotation is 2 centimeters. Okay, so we can say the distance of the lead. Okay, so what is unknown in the question? What force is applied by the screwdriver on the lead? Okay, this is the distance of the lead is equal to what? 2 centimeters. So what is remain here? What is remain? If this is 2 centimeters, what is remain here? 23 minus 2, 21 centimeters. The force applied at the end of the screwdriver, if the force of the screwdriver was given 84. Okay, the distance of the screwdriver is equal to, from the axis of rotation, is equal to 23 minus 2 is equal to 21 centimeters. What is this? This is the distance from the applied force of the screwdriver, which is equal to 84.3 Newton. Okay? Now, what force must be exerted by the lead? The force of the lead, okay? What force must be exerted by the lead on the screwdriver? This is the force of the screwdriver, and this is the force of the lead. These two forces, both of them downward, produces the clockwise direction, which is negative. This is direction, clockwise direction. But this force produces counterclockwise direction, so that is why it is positive. These two torques are equal, okay? So that is why we have to say the positive torque is equal to all negative torque. The positive torque is the torque of the lead, which is equal to the force of the lead. Force of lead times the distance of lead from axis of rotation is equal to the force of the screwdriver and the distance of this, not the entire distance. Please be careful. What do you mean by this distance in torque? Is the distance from applied force to what? To the axis of rotation, not to the end of the screwdriver. Be careful. The entire distance of the screwdriver was given 23 centimeters, but we have to use 21 centimeters to find the force of the lead. Why? Because we have to consider the distance from applied force to the axis of rotation. Okay? Now, we can rearrange the equation. The force of the screwdriver goes to the numerator with its distance, and the distance of the lead goes to the denominator. So, the force of the screwdriver, 84.3, yes? Times the distance, don't try 23 please. Write down what? 21 centimeters, which is equal to 0.21. okay, divided by the distance of the lead, this distance, okay, 0.02 meter. The force of the lead that acting on the screwdriver is equal to 885.15 Newton. Okay, this is question 23. It's a very good question. Okay. Question 36 in chapter review.